Let's look at the support skills for Preview 3 Part A. So in the next preview assignment and in the next class, you will need to be able to use percentages and percentage equations to work with data sets. So if we look at percent, they tell us that the term percent means per 100 and is another way of representing a fraction with a denominator of 100. Remember, in fractions, the denominator is the bottom portion of the fraction. Percentages are always expressed with a percentage sign, which is this symbol at the end of the line. Percentages can consist of numbers between 0 and 100, but it is also possible to have a percentage greater than 100. Percentages may also involve decimal values. Let's look at an example. According to 2017 data from the Federal Aviation Administration, the FAA, about 7% of all pilots are female. This means that out of 100 pilots, 7 of them are female. You can convert this percentage to a fraction or a decimal. So if we look at Part A, it says write 7% as a fraction. So I'll take that 7 from the 7%, so whatever's in front of the percent sign, and put it over 100. Because remember that 7% means 7 per 100. That's how we get our fraction. If we look at Part B, they ask us to write 7% as a decimal. So there's a couple ways to think through this. If you think about the fraction that we just wrote, the 7 over 100, we know that a fraction bar really means division. So I could write that 7/100ths as 7 divided by 100. Then I'll pull up my calculator and do 7 divided by 100. When we do that, it gives us this decimal answer, 0.07. So that's our answer as a decimal. Now, in previous classes, you may have learned a shortcut. So if you think about that 7%, we can look at where the decimal is, or that decimal point is. So whenever we have a whole number like 7, the decimal point is at the end of the number. So to get from this percent, 7% to a decimal, the shortcut is that we bump the decimal point 2 spaces to the left. And if we do that, any blank spaces we have, like this one right here, we would just fill in with a 0. So we could also find that 7% is 0.07. Now, the way to remember which way to move your decimal point, or the way I remember it, is I think about alphabetical order. Right? In the alphabet, D comes before P. So if we think of this D as representing our decimal form and the P as representing the percent form, then if we want to go from a percent to a decimal, we'll move 2 spaces to the left. And we can actually reverse it as well. If we start out with the decimal and want to go to a percent, we can use a shortcut and move that decimal point 2 spaces to the right. So if we think about the decimal 0.07, if I wanted to get this as a percent, I would bump that decimal point 2 spaces to the right, and it would give us that 7% back. So let's look at another example. When we complete this table, we're going to write each number as a percentage, a reduced fraction, and a decimal. So it's going to give us practice moving between those 3 different forms of a number. So if we look at this percentage, 120%, we can use that same strategy we talked about before. We can take 120 and put it over 100, because a percent always means per 100. Now, one thing I want to point out is that they tell us we need it to be a reduced fraction. So if you want to do this by hand, you can, and find common factors and divide them out. But we have a calculator, so I can do 120 divided by 100. When I do that, it gives me my answer in decimal form, but if I click this fraction button in the circle, it'll give me the fraction in reduced form. So it'll give me 6/5. So my final answer for that fraction in reduced form is 6/5. Then to get that decimal answer, if we look back at that calculator again, we can just unclick the fraction button and get our decimal answer of 1.2. If we look at this next row, they give us the fraction 5/4. So I know to go from a fraction to a decimal, I can divide. So I can do 5 divided by 4. If I pull up that calculator, 5 divided by 4 gives me 1.25. So my decimal answer is 1.25. So if we kind of try to figure out how we can go from this decimal over to a percentage, let's first think about how we went from a percentage to a decimal. Right? We did that by taking that 120 and dividing by 100. So if we're going in the other direction, if we're undoing it, we're going to multiply by 100. So I'm going to take this 1.25 and multiply by 100. If I do that, we find it's 125. So our percentage is 125%. If we look at this next one, our decimal is 0.456. So we know to go from that decimal to the percentage, we can multiply by 100. So if I take that 0.456 and multiply by 100, it gives us 45.6. So we have 45.6%. If we try to go from this decimal to the fraction, what we can do is use our place values. So remember, if we have this 0.456, the 4 is in the tenths place, the 5 is in the hundredths place, and the 6 is in the thousandths place. So if I wanted to read this correctly using my place values, I would read it as 456 thousandths. So I can write this as 456 over 1,000. So just using those place values can help me figure out what's going on in that fraction form. And now if I simplify it, I have 456 divided by 1,000, and I'll hit the fraction button. It tells me in simplest form that's 57 over 125. If we look at this last row, we have 1.6%. So if I try to go from that percent to a fraction, I would take that 1.6 and put it up in the numerator and put it over 100. Now the issue is when we have fractions, we can't have decimals inside that fraction. So if I go to the calculator like I've been doing to try to get my simplest form, if I do 1.6 divided by 100 and click my fraction button, it tells me that in simplest form, it's really 2 over 125. And then for that decimal, I can go back to the calculator and just look at it in decimal form. It's the 0.016. So let's look at a few word problems. To solve these word problems, we're going to need our percentage equations. So to solve problems involving percentages, they're telling us to use the formula part equals percentage times base. So if we look at these sentences underneath, they explain this formula. They tell us that problems involving percentages involve first determining what is known and what is unknown. So sometimes we won't know the part, sometimes we won't know the percentage, and sometimes we won't know the base. You then solve the equation for the unknown value. And using the formula, the percentage gets converted to a decimal value. So this percentage has to be in decimal form. So for example, instead of writing 7% in our equation, we would use 0.07 in our equation. The other thing to keep in mind is that the base is the whole quantity defined in the problem. So you can also think of this equation as part equals percentage times whole instead of base, if that makes more sense to you. If we look at number 3, it says according to the FAA, there were 149,121 flight pilot students in 2017. 19,219 of whom were female. What is the base value for this problem, and what is the part value for this problem? So remember, the base is the whole, and the part is the piece, right? It's a part of that whole. So if we look at what's going on, we're measuring flight pilot students and then female flight pilot students. So the base, the whole, is that whole 149,121 flight pilot students. The part is those students that were female, the 19,219. I want to point out this 2017 is just a year, so we're not going to actually use that number. So if we look at part B, it says what percentage of flight pilot students were female. Show your work and round to the nearest hundredth of a percent. So if we use that formula, part equals the percent times the base. The part we identified as 19,219. The base we identified as 149,121. So the percent is what we don't know. So we usually put a variable in for what we don't know. So I'll use X. So I don't get confused. Instead of using X as a time sign as well, I'm going to use the dot as a time sign. So our goal is to get this X by itself. When we solve equations, we undo operations. It's X times that number. So to undo that multiplication, we'll use division. So I'm going to divide both sides by 149,121. On the right-hand side, those numbers cancel out, so I'll just be left with X. On the left-hand side, I need to go to my calculator. I need 19,219 divided by 149,121. When I do that, I get this long decimal, 0.128881947. So it was 0.128881947. So what we need to remember is when we use that equation, our percentage is in decimal form. So this answer that we just got is our answer in decimal form. To go from a decimal to a percent, we need to multiply by 100. So I'll multiply by 100 to get it in percent form. I need to hit my answer times 100, and that gives us the 12.88819147. Percent. And then notice they told us to round to the nearest hundredth. So we have tenths, hundredths is this 8. The 8 next to it tells us to bump it up. So for our final answer, we'll have 12.89%. And that's answering this question, what percentage of flight pilot students were female? So 12.89% of students were female. Let's look at another word problem. It says the FAA reported that 9,971 women were private pilots in 2017, or 6.14% of the total number of private pilots. So for part A, they're asking us what values are given. So if we think about that equation, remember it's part equals the percent times the whole. So we need to figure out what two of those three did they give us. So they told us how many women were private pilots, and they told us that 6.14% of the total number of private pilots, so that this number of women was that part of the total number of private pilots. So they gave us the part, the 9,971 women, and they did not get, and they did give us the percent, the 6.14%, but they did not give us the whole, right? That whole is the total number of private pilots. If we look at part B, it says how many private pilots were there in 2017? Show your work and round to the nearest whole number. So we're going to use that part equals percent times whole or times the base. For that percent though, we have 6.14%, so we need to divide it by 100. If we do that, we'll have 0.0614. So we'll have 9,971 equals 0.0614, and we don't know the whole, so it'll be times x. I'm going to use x to represent the whole. Just like before, this right-hand side of the equation has multiplication. To undo multiplication, I need to use division. So I'll divide by that 0.0614, and whatever I do to one side, I must do to the other. On this right-hand side, they cancel out, so I'm just left with my x. On the left-hand side, I need to actually do the division, so I'll pull up my calculator. I have 9,971 divided by 0.0614, and that gives us this large number. So 162,394.1368. So 162,394.1368. But we need to think about what this X represents, right? It represents how many private pilots there were in 2017. We can't have part of a person or part of a pilot, so we'll round to the nearest whole number. The 1 tells us to leave that 4 alone, so we'll say that there were 162,394 private pilots. Now let's switch gears a little bit and talk about populations and samples. So we've got a definition that a population consists of all subjects being studied, and a sample is a group of subjects selected from the population. So in this case, the sample is the part, and the population is the base or the whole. So a polling company is interested in determining how many voters in a city favored a particular candidate. There are 208,655 voters in the city. The company surveyed 2,500 of these voters. In the survey, 200 people favored candidate A. So if we look at part A, they ask us how many people are in the population and how many are in the sample. So remember, the population is all the subjects being studied. The sample is the group of subjects selected from the population. So if I look back, they tell me that there were 208,655 voters in the city. They tell me they surveyed 2,500 of these voters, and in their survey, 200 people favored candidate A. So if I'm thinking about the population, right, that's all of the voters. So the population is that 208,655 voters in the city. For Part B, they ask us what percentage of the population is in the sample. Round the percentage to the nearest tenth. So, we already know the population. Now we need to figure out what's the sample. So we have left over how many people were surveyed, and then within the survey, how many people favored candidate A. So the sample is the one selected from the population. So this survey is the sample. So if we think about that equation we talked about, right, we said the part equals the percent times the whole, or times the base. So the part was the survey, the 2,500. We don't know the percent, that's what we're trying to find. And the whole was the 208,655. I need to undo that multiplication to solve this equation, so I'll divide both sides. I need to use my calculator for that division, so I'll do that 2,500 divided by that total amount, so the 208,655 people. So that gives us the 0.011981500056. So I know I'm not going to remember that whole number. So it was 0.011981500056. Now remember, that's our percent in decimal form. So we need to get that answer in percent form. So I'm going to take that answer and multiply by 100 to get it in percent form. So we'll have 1.198150056. If we look at our directions, they told us to round the percentage to the nearest tenth. So my tenths is one digit after that decimal point. So that 9 tells me to bump it up. So we'll have 1.2% of the population is in the sample. One important thing that I want to point out here, make sure you don't round until after you've already converted it to percent form. So don't round when it's in decimal form, round once you've converted it to decimal form, or once you've converted it to percent form. Round at the end. So if we look at Part C, they ask what percentage of the sample favored candidate A. Is this the same as the percentage of all voters in the city? Explain. So let's focus on the first part. What percentage of the sample favored candidate A? So we've got that part equals the percent times the whole, or the base. So in this case, we're treating the sample as the whole, and those people that favored candidate A as the part. So if we look back up, they told us 200 people favored candidate A, and the survey had 2,500 people. So we'll have 200 equals that percent, which we don't know, so it'll be X, times that survey whole, so the 2,500. I'll divide both sides by 2,500. If I do that, right, we have 200 divided by 2,500. That gives us 0.08. Remember, that's our answer in decimal form, so I'll multiply my answer by 100 to get my answer in percent form, which would be 8%. So when we just did the division, we got 0.08 equals X. That 0.08 times 100 told us we had 8%. Now if we think about that next question, is this the same as the percentage of all voters in the city? our answer is no. And it's because the sample is only one part of the total population. Let's look at Part D. It says on election day, 127,530 people cast their vote. What percentage of voters in the city voted? Round the percentage to the nearest hundredth. So we know our percentage equation is part equals percent times the whole or times the base. So they tell us how many people cast their vote. We're trying to find what percentage, so we don't know the percent, of voters in the city voted. So the total voters is going to be our whole. How many people voted is our part. So that part is the 127,530. We don't know the percent. And that whole was this total number of voters in the city, the 208,655 people. So to find the percent, we divide. And whatever we do to one side, we must do to the other. So if we use our calculator, we need to do 127,530 divided by 208,655. That gives us our answer in decimal form. To get in percent form, we need to multiply by 100. So I'm going to take the answer, multiply it by 100. So that gives us 61.12003067%. If we look at our directions, they told us to round the percentage to the nearest hundredth. So 2 is in my hundredth spot. The 0 tells me to leave it alone. So our final answer would be that 61.12% of voters in the city voted. If we look at Part E, they're asking us how many votes did the poll predict candidate A would receive. So if we look back up to Part C, right, we figured out that based on the survey, 8% of the survey voted for candidate A. So what we could say is based on that survey, we think 8% of those votes would go to candidate A. So if we're thinking about that part equals the percent times the whole or the base, the part is how many people actually voted for candidate A. We don't know that, so that's our X. The percent is that 8% in decimal form, so that 0.08. And how many votes the poll predicted candidate A would receive. So that means the whole would be based on the number of people that actually voted. So it would be that 127,530 from Part D. So if we do that multiplication, we'll have 0.08 times 127,530. So that gives us 10,202.4. This was voters, so we still need a whole number. So we'll say 10,202 votes. Right. One thing I want to point out with this equation, notice we didn't need to undo anything because the x was already by itself on the left-hand side.